Good afternoon. I am Amir McKean, electrical engineer, founder of AIC Publications. And this is the first lesson in our AIC Publications 10-minute engineering program. This is going to be the first tutorial. And the lesson that we're doing right now is entitled, Where Does Electricity Come From? All right, let's get into it now. Energy is not created or destroyed, but it's transformed from one state to another as a result of an action upon particles. Contemporary science has defined energy as the ability to do work. Physics has defined work as the force applied on a particular particle or an object in both magnitude and direction. Now, depending upon the particles at work, the resultant energies can be either potential, they can be kinetic, mechanical, thermal, which is temperature, hydro, which is water, and many, many others. Now, in order for us to put the energy to applicable use, we can define it in both mathematical expression and word. Each energy form has different forces that impact its function. The particular form of energy that we will focus here on the AIC Publications 10-minute engineering program is going to be electrical energy. This study, the analysis, the tutorials, the activities that we're going to be doing, all of the ebooks that we're going to develop, the Black Stemporium podcast, everything is going to be a part of what is called by contemporary society as science, technology, engineering, and math, or STEM. Now, this term, even though it's fairly new in terms of a term, is the concepts behind it are as old as, human activity. So we're going to break down right now the acronym for all four of these. And I am aware that there are some individuals that put the A in STEM, which stands for art. But for our purposes, we're just going to focus on STEM. All right. Now, the S in the science. And the way that I define this, I'm going to define this in a way that I want you to get your mind wrapped around this. All right. In a particular way. So we define everything in AIC publications in a way that can relate to our audience and that can make the target group that we're trying to serve able to center themselves into this activity and into this subject matter. So, science is simply a creative activity that often resembles other creative activities of the mind. Technology is using the understanding of the resources in the world around us to generate applicable solutions for problems that are common to all people in human society. Engineering is the use of the critical thinking skills necessary to determine which application is the most accurate and best fit for the solution. Mathematics is the universal language that connects the science, the technology, and the engineering together. Mathematics is the bridge that puts all of that together. All it is a language that we need to learn how to speak, how to read, how to write, and then be able to converse in that language with others who are also engaging in science, technology, and engineering. To not allow ourselves to be intimidated by this, you should know that STEM as a thing or a concept can be implemented, executed, or performed through this simple acronym, through verbiage. All right. So now I'm going to break down STEM, and meaning that you can perform STEM through four different uh, action verbs. All right. And I call it creativity, understanding, determining, universality, or the acronym is CUDU, CUDU, which means You're going to be using your creativity in your mind. You're going to be using the level of understanding that you have about the concepts we're going to go over. Then you're going to take those two and you're going to determine the best building block that you can create so that it will be universal to every single person. In other words, you're solving a problem that's common to everyone. So that's the CU, the DU, kudu, creativity, understanding, determining, and universality. That is the action behind science, technology, engineering, and math that we're going to focus on here in the Black Stemporium podcast and the AIC publications platform that we create. All too often, the traditional education approaches science, technology, and engineering in a very disconnected and disjointed way. When it's taught this way, the student, whether that student be an elementary, a middle school, a high schooler, or even a post high school individual, or let's say even an adult that may want to shift their career focus and tackle science, technology, engineering, and math, they begin to be forced to separate the different concepts because this is the way they're taught. And it explains how the universe exists and functions as one big machine. In other words, the way the conventional approach to STEM is being taught is it disconnects the person that is learning from how the universe takes one particular piece and being able to see that person in the center of that universe. So therefore, their mind can't really connect with the concepts that are being taught through STEM. So the interconnectivity and the interdependence that's necessary to understand, it doesn't connect with the student. That's what makes our 10-minute engineering program completely different. Now, this approach, meaning the traditional education approach that I'm criticizing and having a problem with, this especially leaves behind the Black African American student. A 2022 Pew Research study confirmed that 67% of Blacks surveyed view engineering as a field that is unwelcoming to them. That same 64% of Blacks also believed that the current representation of Black engineering in various fields, they've already topped out in success in their various fields. So that means you've got nearly 2/3 of Black African Americans who believe that the current representation of engineering, which is made up of myself and other several individuals, have already topped out in terms of what we're going to be able to do. I find that very problematic. And we're going to go over each of these data points and deconstruct them. Consequently, as a result of this traditional approach, the natural tendency that the student has to ask relevant questions such as, oh, what is this used for? Or how is this going to be helpful to me? They never get answered in the young, burgeoning mind that might be interested in this. Here's an example. When science courses are typically taught, educators usually almost always start with a mathematical formula. They put it on the board, they put it on the whiteboard, they put it on the computer, and the students are told, burn this formula into your mind in the manner of some problem that the teacher or the professor or the facilitator is putting up to be solved. The student automatically becomes bored and unable to relate due to this approach. Rarely are they given examples that are relevant to themselves. This leaves them disincentivized to place themselves in the center of the why, the how, and when this subject matter will directly impact them. And the data that has been researched on all of this also bears this out. So we here at AIC Publications, we're going to explore all of this and more as we proceed with our content development. We're going to unpack and extrapolate on many of these data points so that you can understand the why behind all of it. Because once we understand why, we can successfully deconstruct it. We can then build upon a plan of execution for success in spite of all of this troubling data that you have to be aware of. Thousands of years ago, man began to realize that crystals found in the earth made of different materials, when heated or cooled, could create amounts of what would later be known to the world as electricity. This generation of electricity from this is called the pyro effect, and it still exists today. Electricity is literally a flow of electrons. This is critical and key to understand because in their raw state, electrons, when they move, are not organized, but they're very chaotic, and they will move anywhere the environment or space around them allows. When we begin to control the how, where, when they move, and through what material they move, we call that the study of electricity. Oftentimes, you're going to hear the terms electrical engineer or electronics engineer used. Sometimes I myself, I'm even asked about when to use electrical versus electronics. Now, let's explain a little bit about this. When we study electricity, we're also using physics and mathematics to be able to predict how the flow of electrons will impact our design, whether that design is a cell phone, a television, or our own circuit that we build, how we can manipulate the flow of electrons to create a widget, whether that widget be an electric car or a video game that can do exactly what we want when we want. Once we start using electrons to build or construct widgets such as these, we can then say that we're actively using electricity or electronics. Using physics and mathematics to understand how the widgets can be constructed and be able to predict how they will behave under certain conditions, that becomes known as electrical analysis. So when discussing electricity, we talk of a high quantity of electrons, and we call a certain number of electrons a charge. That certain number of electrons happens to be 6.625 billion electrons, and we call that a coulomb. So anytime that you have at least that amount of electrons, that is corresponding to just one coulomb. Now, we use this because in reality, it's very, very difficult to count electrons one by one. So the coulomb creates a uniform standard for charge by counting a designated number of electrons. Now, when understanding the term electronics, we're taking the electrical analysis and adding to it what are called active devices. An active device is a device whose electrical behavior only occurs when power is applied to it, or simply when it's plugged into an outlet. Active devices would be items such as transistors, operational amplifiers, voltage regulators, and many others. A passive device is a device whose electrical behavior remains the same if power is not applied to it, or simply when it's not plugged into an outlet. Passive devices are devices such as resistors, capacitors, inductors, and a few others. Now, we will cover all of this in the Black Stimporium podcast and the AIC Publications 10-minute engineering program as we continue to go forth.